Okay. Um, Next section is 10.2. So what we're going to do is start talking about types of sequences. So we saw a whole slew of sequences last time. Um, Things with these very simple ones like here, and this is what we're going to be studying in this next section. But we also saw ones like this, and they all have kind of patterns to them. We saw a recursive sequence. This guy here is pretty crazy. So we want to study sequences like we studied different kinds of functions, right? We created a zoology of functions. Now we kind of want to create a zoology of sequences, and we're not going to take it too far, but we're just going to look at two types of sequences, the arithmetic and then the geometric. And 10.2 is about the arithmetic. So it's pretty simple. It's the first kind we looked at in 10.1, where every term just differs from the previous term by adding something in. So the sort of general definition is that a sub n, and this is a recursive definition, a sub n is equal to a sub n minus 1 plus some value. And this value here is called the common difference. Right? So for example, when we had our first example from 10.1, we had 1, 3, 5, 7, blah, blah, blah. We could describe this by saying a sub n is equal to the previous guy, a sub n minus 1, plus, well, what? Well, to go from 1 to 3, I have to add in 2, right? So the recursive formula for that sequence is a sub n equals a sub n minus 1 plus 2, right? Very simply. Okay, so let's look at maybe what the book is doing here at this point. Problem 1, they give you a sub 1 is 200, and the difference, the common difference is 20, and they want you to produce the first 4 terms of the sequence. Okay, so of course a sub 1 is 200, and then to get to the next one, you just add 20 to the one before it. Okay, so the next guy is 220, and then the next guy must be 240, and then 260, and on and on. So pretty simple. You don't have to always have an increasing sequence. Okay. So in problem 6, we see a decreasing version. This time we go down by 60 every time. So I'll start at 200. And then to get to the next one, you take 60 away from 200. So this will be 140, and then 80, and then 20, and you can have negative terms in your sequence. That's fine. So eventually we'd have to go down farther. Let's say number 12. So this time they give you the formula, the recursive formula, and they want you to figure out the first 4 terms of this sequence. Okay. So a sub 1 is given as 50, so we start there. And then the formula is saying to get to the next term, you just take 20 away from the previous. Okay, so 50 and take away 20, we get 30. Take away 20, we get 10. Take away 20, you get negative 10. And yeah, there it is. We can have negatives in sequences. Okay, no big deal. Okay, so we want to produce a general formula for the sequence. If you remember last time, our general formula for a sub n was actually 2n minus 1. Okay? So now we want to produce this thing right here. How, when given this sequence of numbers, can we produce the formula for that sequence? I mean, we could guess at it, certainly. But is there a nice way, a nice method that we could program into a computer, for instance, and have a formula on hand then? So yeah, there is. Section 2, the general term of an arithmetic sequence. Okay, and we could kind of guess this. In a more advanced course, we would probably prove it via induction, but for here, I think we're just going to guess it. Okay, so note a sub 1 is equal to a sub 1. A sub 2 is equal to the previous guy plus this d value, this difference value. So that we're using the recursive formula to produce a general formula. Okay, and we're going to do it by iteration, by pattern recognition. Okay, so a sub 2 is a sub 1 plus the common difference. And then a sub 3 is equal to a sub 2, which was a sub 1 plus d, plus like another d. Okay, so this would be a sub 1 plus 2 d's. A sub 4 then is a sub 3, which is a sub 1 plus 2d. And then you add in another d. So hopefully you could see there's this formula, going on here. So if I want to know a sub 5, over here, a sub 5 I bet is a sub 1 plus, well, when we had 3, they gave us 2 d's. When it was a sub 4, we have 3 d's. So when it's a sub 5, we must have 4 d's. And then we could guess our general formula, a sub n. Well, that must be a sub 1 plus 1 less than n, so n minus 1 times d. And that's our general formula. Okay, so let's apply it to that first example just to prove that it really is what we thought it was. So a sub n must be a sub 1 plus n minus 1 times d. So in this case, a sub 1, the first term was 1, and then plus n minus 1, and the difference, the d value is 2. We're adding in 2 to get to the next value every time. And then we could simplify this formula. So we'll have 1 plus 2n minus 2. 2n minus 2 plus 1 then is 2n minus 1, and oh yeah, we got it. So it does in fact give you that nice formula that, otherwise I don't know where it's coming from, right? You have to guess at it or whatever. No, you can use this formula to produce the general formula for the terms of the sequence. Okay, so this will allow us to basically pick off any term of the sequence that we require for our work. So let's look at 16. Find a sub 16 when a sub 1 equals 9 and d equals 2. Okay, so our formula a sub n is going to be a sub 1, which is 9, plus n minus 1 times d, which is given as 2. Okay, so this is 9 plus 2n minus 2, which is 2n plus 7. So a sub 16, all I have to do is plug 16 into this formula and I got it. So it's 2 times 16 plus 7. 2 times 16 is 32 plus 7. So the 16th term must be 39. Okay? So it gives you a quick way, instead of having to go through and go 9, and then the next guy is 11, and the next guy is 13. No, you just skip all the way ahead to the 16th term is 39. Saves you a little time, right? Okay, good stuff. So let's look at 24. Find the formula for the general term. Okay, so we're looking for this a sub n formula in these problems. We have 2, 7, 12, 17, ... Okay, so for the a sub n formula, we need two things. We need a sub 1, and we need the difference. So the first term is 2. The d term, you just take the difference between a sub n plus 1 and a sub n. Okay? So you just take two consecutive terms and subtract them. And you can pick any terms you want. Let's pick 17 and 12. Well, that's just 5. Okay. So we got our information. A sub n must equal then a sub 1, which is 2, plus n minus 1 times 5. Okay, so that'll equal 2 plus 5n minus 5, which equals 5n minus 3. Okay, let's look at 26. So we have one going in the other direction. 6, 1, negative 4, negative 9, dot, dot, dot. This time a sub 1 is 6, and then the difference between two consecutive terms is going to be, well, let's take two of them. Negative 4, subtract away 1, apparently negative 5. Okay. So a sub n must equal a sub 1 plus n minus 1 times d, which is negative 5. And then that'll equal 6 minus 5n plus 5. So it'll be 11 minus 5n. Okay. There is one small issue which doesn't come up in our class, but it comes up eventually, and you might as well, somebody should talk about it. It's what happens if I want to start with my first term being 0. So instead, let's say I have 1, 3, 5, 7, dot, dot, dot. Instead of saying I want a sub 1 to be 1, let's say I wanted to start at a sub 0 to be 1. Can I use the same formula? Okay, so in this case, it's going to be, the formula is a sub n equals a sub 1 plus n minus 1 times d, which the d value is, of course, 2. So it's 1 plus 2n minus 2, which is 2n minus 1. Okay. The problem is, if you started at 0 and you put 0 into this formula, you would get negative 1. And then when you put in 1, you get 1. And then when you put in 2, you get 3. So if you start at a sub 0, it's not going to work. You have to start at 1. So let's say I wanted to start at a sub 0. What would then be the formula here? Well, you can again do this iteration approach and say, well, a sub 0 is a sub 0, and then a sub 1 is a sub 0 plus d, and a sub 2 is a sub 0 plus d, which is 2d. And then in general, your formula then, a sub n, is going to be a sub 0 plus n times d instead of n minus 1. Okay, so the formula when you start at 0 is going to be just that. A sub n equals 1 plus n, which is 2, times, d, which is 2, times n. So the formula when you start at 0 is 1 plus 2n. So the first guy, a of 0, would be 1 plus 2 times 0 is 1. A sub 1 will be 1 plus 2 is 3. And you're getting this sequence right here. It's just you start at this other place. So the book doesn't talk about it, but when in general, if you start with I equal to 1, then your formula will be a sub n equals a sub 1 plus n minus 1 times d. If you start with I equaling 0, it's basically a matter of shifting this formula over 1, and you'll have a sub n equals a sub 0 plus n times d. Okay, but anyways, our book will focus in on this formula, and that's fine for us and for getting your homework done. Okay, but in reality, you're going to have to deal with these issues where you're not starting at I equals 1. You'll be having shifted sort of start places. Okay, anyways, let's move on to sums of arithmetic sequences. Okay, so it actually produces a new kind of sequence, and it's called a sequence of partial sums. Okay, so it's a bit weird, and obviously there's all kinds of sequences in our zoology of sequences, and some sequences will be more important for our work than others. And one that comes up in calculus is the sum of sequences, a sequence of partial sums. Okay, it's good for doing approximations. So what is this? Well, each term will be the sum of terms of a sequence, basically. So S sub 1, the first sum is A sub 1. The second term of this new sequence is formed by adding the first two terms of the sequence A sub n. And then the third term, the third partial sum will be A sub 1 plus A sub 2 plus A sub 3. And you can continue on all the way up to the nth partial sum, which is A sub 1 plus A sub 2 plus A sub 3 plus dot 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 plus A sub n. Okay. So in general, we want another formula for this when it's an arithmetic sequence. And we can kind of guess at the formula using just iteration methods again. Okay? So what's it going to be? Well, let's take a look. In actuality, let's play around with a simple version of this. Trying to think of how I want to do this. Sorry. Just give me 1 second. Oh boy. Well, let's look at a simple version of this problem. So note the sum 1 plus 2 plus 3 plus 4 plus dot 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 all the way up to 100. Okay? And we want to get a formula for this. Okay? So we know S sub 1 is going to be 1. S sub 2 is going to be 1 plus 2, which is 3. S sub 3 is going to be 1 plus 2 plus 3, which is 6. And so on, right? And we want this formula for S sub n, which is 1 plus 2 plus 3 plus dot 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 plus n. And it's kind of like, I don't know, you know? Sorry, I went off the page. So S sub 1 is 1. S sub 2 is 1 plus 2 plus 1 plus 2, which is 3. S sub 3 is 1 plus 2 plus 3. So the sequence of partial sums is 1, 3, 6. And we're trying to guess what this last S sub n formula is. And it's like, I don't know. You know? One thing we could do is kind of split it up, you know, in a weird kind of way. So what I'm going to do is add it to itself. I'm going to say, let's take S sub n, and this is kind of unusual, but just go with it. So it's 1 plus 2 plus 3 plus dot 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 plus 100. Okay. And then we're going to add it to itself. Okay, but we're going to add it in a weird kind of way. I'm going to write it in reverse here. So 100 plus 99 plus 98 plus dot 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 plus 1. Okay. And so what do you get? Well, S sub n plus S sub n is 2S sub n. And then what do you get over here? Well, it's always going to be 101. So you get 101 plus 99 plus 2 is 101 plus 101 plus all the way up to 101. Then you could write it as 2s sub n equals, well, how many 101s are there? Well, it counts them off right here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 100 101s. So 100 101s is 100 times 101. And then we can divide both sides by 2, and we kind of have our answer. Okay. We could do the same procedure in general with any arithmetic sum. Okay, so I could say, instead of this, let's keep it in terms of the formulas. A sub 1 plus a sub 2 plus a sub 3. How does this work? I've kind of forgotten how it works. All right, so S sub n equals a sub 1 plus a sub 1 plus d plus a sub 1 plus 2d plus dot 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 plus a sub 1 plus n minus 1 times d. Okay, and then add it to itself, but write it in the reverse order. Okay, so I'm trying to mirror what I did with this previous thing, but in a more general kind of way. Okay, so the first one, 1, and then 1 plus 1, and then 1 plus 2 times 1 is 1 plus 2 is 3. It's that sort of idea. So a sub 1 plus d, you should write it like this. And then I want to go in the reverse direction. To go in the reverse direction, what I do, I start at a sub n, and then go plus a sub n minus d. So in the other direction, it's a sub n plus a sub n minus d plus a sub n minus 2d plus dot 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 plus a sub n minus n minus 1d's. And then if you add them together, you kind of get the same weirdness going on. We'll have 2 s sub n's here, and then over here you'll have a sub 1 plus a sub n, plus, and then what is this? The d's will cancel, and you'll get a sub 1 plus a sub n, and plus a sub 1 plus a sub n, and then plus all the way up to a sub 1 plus a sub n again. And then you ask yourself, well, how many were there? Well, there's 1, 2, 3, all the way up to n minus 1 plus 1 of them. In other words, there's n of them. So you have n times a sub 1 plus a sub n. And then divide both sides by 2. And you get n all over 2 times a sub 1 plus a sub n. But really what I've done is just the same exact thing I did with this particular summation. So I just wrote it increasing and then wrote it decreasing, added them together, divided by 2. That's what I did here. Write them increasing, write them decreasing, add them together, divide by 2. And the result is a very handy formula for us then. This will be the general formula that we can apply to any sequence. Okay, so let's apply it to homework problems. And here we start with number 30. Okay, so find the sum of the first 25 terms. And this is definitely something you don't want to do by hand, right? You don't have to sit there and add these in your calculator. You could, but you don't want to. Okay, so there's our given arithmetic sequence. We need the formula for, well, we need a sub 1, we need a sub n. So a sub 1 is easy. That's just 7. A sub n, though, a little more complicated. I need to figure out what is that thing. So a sub n is equal to a sub 1, 7, plus n minus 1 times the difference. So the difference here, if you subtract two terms, you're going to get 19 minus 7 is 12. Okay, so this would be 7 plus 12n minus 12 equals 12n minus 5. Okay, so our formula for the sum of the first n terms is n over 2 times a sub 1 plus a sub n. We want the first 25 terms. Okay, so the only thing we really need is a sub 25. We know everything else. A sub 25 is 12 times 25 minus 5. 12 times 25 minus 5, I think it's 295. Let me get my calculator. Yeah, okay, we're good. And then just plop all this information into your summation formula. So we want, in particular, S sub 25. That's going to be 25 over 2 times a sub 1, which is 7, plus a sub 25, which is 295. Okay. And I'll put that in my calculator. And I'm getting 3775. Let's look at another one. So 44. Find the sum of odd integers between 30 and 54. So you can think of it, the sum of the odd integers as the sum of the sequence 31, 33, so 31 plus 33 plus 35 plus dot, 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 all the way up to 53. Okay, so a sub 1, of course, is 31. Our a sub n formula is going to be a sub 1 plus n minus 1 times the difference between two consecutive values, which is 2. 33 minus 31 is 2. So we get 31 plus 2n minus 2 is 2n plus 29. Okay. So we need the n value for our summation formula. So 53 is what n value? 53, we set it equal to this formula and solve for n. So 2n plus 29. 2n equals 53 minus 29. It's 24. And then n is equal to 12. Okay, so we want the sum of the first 12 terms, which will be 12 all over 2 times a sub 1, which is 31, plus a sub 12, which is 53. So we get 6 times 84. In other words, 504. So we had to do a little bit of extra work trying to figure out the n value to put into our formula. Okay. So we get one more. So 46. The sum I equals 1 to 20 of 6I minus 4. Okay, so what is this thing? First off, plug in 1, you get 2. Plug in 2, 12 minus 4 is 8. Plug in 3, 18 minus 4 is 14. Plus all the way up to 20 times 6 minus 4. 120 minus 4 is 116. So it looks like it's an arithmetic sequence. The difference between each term is 6. Okay? So a sub 1, of course, is 2. A sub n is a sub 1 plus n minus 1 times the difference, which I said was 6. Okay, so we got 2 plus 6n minus 6, which equals 6n minus 4. And of course you see, oh yeah, that makes sense. Okay. So a sub 20, of course, we already know that that's 116. But if you wanted to, you can plug it into here. 120 minus 4 again, 116. So we're doing a bit of redundant work here. Then finally, the sum of those first 20 terms will be equal to 20 over 2 times 2 plus 116. Okay, let's look at the application. And what's happening here is you're going for a job interview, and one company offers this amount and with these sort of raises, a starting salary, and then they tell you they're going to raise your salary by a certain amount every year. Okay, so there's applications. So it's problem 69. You go to your job interview at company A, and they tell you they're going to start you at $19,000 per year, but they're going to give you a raise of $2,600 per year. Okay. And then you go and interview at company B, and both companies want you for some reason. Maybe nobody else wants to do the job. B sub 1 is they're offering you $27,000 per year as your salary. And then they tell you here they're going to increase your salary, but not by as much. So they're only going to give you a $1,200 raise per year. And you kind of have to figure out which is the better deal. In particular, maybe you're only planning on doing this for 10 years, and then you're going to take off to Alaska or something. Okay? So which is better over a 10-year period? And this is really just a sequence problem. So we can use our summation formula of arithmetic sequences to determine the answer here. So in particular, we want to know S sub 10. Right, so the first guy, A sub 1, is 19,000. And then A sub n will be 19,000 plus n minus 1 times the difference per year, which is, of course, going to be that $2,600 raise. Okay, so it'll be minus 2,600 plus 19,000, which I'm trying to figure out what that is right here, plus then 160 or 16,400. Okay, So a sub 10 in this case will equal 26,000 plus 16,400. So a sub 10 will be $42,400. We want to know the actual amount that comes to after 10 years. So we need to figure out S sub 10. That'll equal, of course, 10 all over 2 times a sub 1, 19,000, plus a sub 10, which is 42,400. Okay, so we'll plop that into our calculator. And we're getting a whopping $307,000. Okay. Then we go and do the same thing with company B's information. So their starting salary, they said, was a little better, $27,000, a lot better. And then the raise per year was given as $1,200, so not as good as the other company, but we'll see. Okay. So we need our B sub n formula. So this will be B sub 1, 27,000 plus n minus 1 times 1,200. Okay, so that's 27,000 plus 1,200 n minus 1,200. So 1,200 n and then 27,000 minus 1,200 is plus 25,800. Okay, so B sub 10, we need to figure out our sum. That'll be 12,000 at the end of the day plus 25,800, which will equal 37,800. Okay, so our sum after 10 years of working at that company will be 10 all over 2 times 27,000 plus 37,800. And then you just plop that into your calculator. And you get $324,000. So you can compare the amounts, and obviously you want to go with company B. It seems like you're not getting as big of a raise every year, but in the end, it's going to come down to a bigger amount. So we would want to choose company B. Okay, so that'll do the arithmetic sequences. The next kind are the geometric sequences. So instead of adding something for every term of the sequence, you're going to multiply by something. Okay.